Well, good day and welcome to episode 23 of The Driving Force, presented by the Louisiana Transportation Research Center. My name is Todd Blunt. I'm joined today by my friend, colleague, and co-host, Garrett Wheat.
Good afternoon.
We're really excited that you've chosen to join us here as we highlight the people and projects driving change in Louisiana transportation. For nearly 40 years now, LTRC has merged the resources of our state government and Louisiana universities to identify, develop, and implement new technology to enhance many critical aspects of the transportation system here in Louisiana and beyond. Central to our mandate as an organization is transportation research, and this is the third in a series of episodes highlighting various aspects of that research and introducing the talented and hardworking people who make it happen every day. Our guests today are Dr. Moses Akentuna, who serves as LTRC's Asphalt Research Manager, and Saman Salari, who is one of our awesome asphalt research engineers. We learned from Dr. Sam Cooper on our last episode that there is a lot of careful study and analysis that goes into optimizing the asphalt materials used on Louisiana's roadways for safety, durability, cost effectiveness. And in today's conversation with Moses and Saman, we're going to get a snapshot of several projects the team is working on in pursuit of those goals. Let's take a quick break before we jump into our conversation with Moses and Saman. Welcome back to The Driving Force. Today is the third episode in our research series. We're excited to welcome two of our esteemed asphalt researchers, Dr. Moses Akentuna and Saman Salari. Welcome to both of you. Can each of you begin by introducing yourselves and telling our listeners a little bit about your education and career background? Moses, why don't you start us off?
Absolutely, and thanks for having us. My name is Moses Akentuna, and I'm the Asphalt Research Manager here at LTRC. My journey in this field started way back in my home country, Ghana. I grew up on the campus of what was back then the only university in the country.
Okay.
And I was fortunate enough to be surrounded by a lot of engineering students, and they were also very kind enough to mentor me.
Awesome.
So I ended up enrolling in that university, and I obtained a bachelor's degree in civil engineering. Initially, I thought I'll be a structural engineer, but I got a job working on road construction projects as a site engineer, and that sparked the interest in this transportation and paving engineering, the interest in me. After that, my passion in civil engineering brought me to the United States to pursue graduate studies. And I graduated with a PhD in civil engineering at Ohio University.
Okay.
So from there, my path took me to Canada.
To Canada?
Okay. Where I focused mainly on asphalt chemistry and rheology.
All right.
So my passion also took me back to LTRC in 2018.
Okay.
So I started as a research associate, and I've worked my way to my current position as a manager.
Okay.
And it's been a wonderful experience applying my knowledge in civil engineering to the unique challenges that we have here in Louisiana.
So you've been here in Louisiana for about 7 years now, I was going to ask. That's awesome. Saman, how about you?
Thanks for having me here. I'm Saman Salari. I started, first time I was introduced to asphalt, it was a very messy subject. So I thought to myself that would be perfect for me. So I came to US for my graduate studies at LSU, 2010. I have been around since then. I've been out for 1.5 years, but other than that, I enjoyed working for DOTD for the last 9 years. My subject of interest was mainly asphalt binder, asphalt mixture, and I've been around working on that for these several years in LSU and in DOTD as well.
Okay. Where is your home country?
Iran.
Iran. Truly international here at LTRC. It's awesome. Before we jump into discussion about several specific projects, which we want to hear about, certainly, I'd just love to hear big picture why you enjoy doing this type of research, and how do you see what you do contributing to the well-being of the state of Louisiana and its people? Moses, why don't you start us off?
That's a great question. I believe for me it's about the direct impact of every research we do here on the daily lives of Louisiana citizens. For example, we all do use our roads, right?
Yeah.
We use it to visit family, we use it to go to school or go to work. And for example, if we study here the moisture damage resistance, when we try to evaluate the moisture damage resistance of asphalt mixtures here at LTRC, what we are trying to do is to prevent potholes on our roads. And if there are no potholes on our roads, there's less amount of money that is spent on the repair of those roads. The citizens spend less amount of money repairing their vehicles. There's less amount of time spent on construction traffic.
Yes.
And then the roads also become very safe for our citizens. And we really enjoy what we do, applying all these techniques in solving our unique challenges that we see on our Louisiana roads, making them safer, smoother, and cost efficient for our taxpayers.
Yeah. Sign me up for that, for sure. Saman, what would you add to that?
I just want to say the challenges that research has is very interesting to me. The subject of roads, asphalt binder mixtures that you pass through them every day, and if you look at it day to day, it's not complicated. But if you get deep enough into it, it's one of the most challenging aspects. If we touch every aspect of it, there are challenges to fix, there are challenges to improve, and there are lots of activity around it. So those challenges are what I enjoy a lot. The fact that I don't know what's going to happen, it's one of the interesting facts about them. And the fact that everything we do is actually to help people have a better, a smoother drive.
Yeah, absolutely.
So turning now to a few recent projects y'all have told us y'all would like to highlight for our listeners. Let's begin with a 2025 project focused on something called the semi-circular bin test, which is one of the key testing methods used to optimize asphalt mixtures on the roadways. Moses, can you kind of talk about what you and your team are aiming to achieve through this particular project and how it can enhance construction practices?
Thank you for the question. So this project is all about making our quality control testing more faster and more efficient.
Okay.
So whenever we construct a new asphalt pavement, one of the key ways we test for quality is to determine its cracking resistance. And to do that, we use the semicircular bend test, or the SCB test for short.
Okay.
All right. So the issue with this test is that our standard requires us to age it for 5 days at a higher temperature before we can perform the test. And on construction projects, 5 days is a long time to wait for results.
Sure.
And if you are a contractor and there's a problem with the mix, you need to know it immediately, not to wait for a week.
Yeah.
Especially if the road is going to be open soon.
Yeah. So to address this, there is another team which is part of our group affiliated with LSU. Okay. So they developed a computer model that is based on artificial neural networks. And what this does is that it's able to predict the cracking resistance without going through the 5-day aging process. And what this does is that it provides the contractors with a tool for instant feedback. And with that, they can make decisions on the fly whether they need to adjust their mix components and then improve the quality of our routes. So the purpose of this study is to validate their model to ensure that it's accurate and works, can predict all the type and kinds of mixes we use here in Louisiana.
Wow.
And once we do that, contractors will be able to make decisions as soon as possible. They don't need to wait for a week or 5 days to determine whether they need to make adjustments in their mix. When it comes to testing, the testing steps or the steps we follow in conducting this test is pretty straightforward. So consider a cylindrical shaped asphalt specimen, which is about has a diameter of 6 inches and a thickness of about 2¼ inch. So we cut it in half to form a semicircle.
Okay.
Then on the bottom flat edge, the middle of it, we cut a notch and then place it in a machine that applies a steady force.
Okay.
To break it.
Yeah, from the top at the curved area until it breaks. So after breaking, we measure the energy required for the crack to grow.
Okay.
And the higher that energy, the better that mix will be at resisting cracks on our route. So that's how the test is.
So you're simulating a traffic load and seeing what it can take, basically.
Yeah.
Okay. Saman, I want to turn to you. There's a lot of different angles from which we can evaluate the quality of asphalt mixtures. One of these relates to the mixture's chemical properties, and you've been investigating this through a process called Sarah fractionation. Can you just briefly explain to our listeners this process and what you're hoping to learn through this project?
So, when we are looking at the properties of asphalt, properties of complex material like asphalt binder mixture, we can look at the whole material. It's the mixture test, for example, what SCB testing that Moses is doing. Or you can go back to the original materials like aggregates or asphalt binder. Okay. Aggregates tend to not change properties over time. However, asphalt binder, because of the chemistry of it changes the property over time. So that makes it more challenging. This is why that in this project specifically, my focus is actually to look at those chemical properties. As Moses brought up, we have the cracking performance. This is a performance that usually over time, we actually face more trouble toward that. What is the main contributor? One of the main contributors toward this problem is asphalt binder. How the chemistry of asphalt binder would actually contribute to these problems is actually what I'm trying to correlate through chemistry of this. Another topic that brought up by Dr. Cooper was actually to add different additives into asphalt binder. He brought up the waste materials that can be introduced into the asphalt mixtures, and all those additives, all those materials would change the property and chemistry of asphalt binder. It probably would change the behavior of asphalt binder over time. So because of that, I'm trying to look into the chemistry of asphalt binder. We have a common devices like GPC, gel permission chromatography, and those devices are very expensive, very time-consuming, and the way that they look into the chemistry of asphalt binder is through molecular weight. It's not the chemistry of we correlate those molecular weight to the chemistry of asphalt binder components. However, this Sarah method that I'm looking at is actually tries to look directly into the chemistry. And then we would be able to see the changes into the chemistry. So this is my goal, to try to make sure that we have a prominent method of investigating the chemistry of asphalt binder and then introduce it to our industry, our people in DOTD.
Moses, you've been working on another project we'd like to discuss, aiming towards evaluating non-destructive testing methods. So first of all, can you give us an example of a non-destructive testing, also called NDT, because it seems like a pretty innovative use of emerging technology? And then can you give some context as to why expanding the use of NDTs would be advantageous to the state?
So NDT simply stands for non-destructive testing. So the project is simply about moving away from our old way of doing things, where non-destructive means we are moving away from destroying the very road we've constructed.
Sure.
So traditionally, after constructing a road, we need to assess the density and then pay the contractor. So that means we have to take cores from the road. And it leaves our roads unsightly because it will have to be patched. We'll have several patches on the new road. It's time consuming. It's not very safe because you have sometimes people will be quarrying with traffic moving by.
Yeah.
And not very efficient. So we are moving towards using these non-destructive techniques where we don't need to destroy the pavement by just placing a high-tech equipment on the roads and to get our density. No more drilling, no more coring, just place whatever device it is on the road and then it spits out the densities for you.
Wow.
And these non-destructive equipment, they usually come in two categories. So we have the nuclear non-destructive density gauges, and then we have the non-nuclear.
Okay.
So the nuclear ones are very effective in measuring density, but they do have radioactive sources, and because of that, they have significant safety concerns and regulatory challenges, especially in their training, transportation, and storage. So because of that, people or agencies prefer the non-nuclear options. And one example is the electronic gauge that we are evaluating in this project. Okay. So that electronic gauge, what it does is that we place it on the safe surface of the newly constructed road, and it sends electric current, small electric currents, into the pavement, and then measures the electrical properties of the road. And we can then correlate that to density.
Okay.
So the objective of this project is, as I said, we want to move away more into not turning our roads into Swiss cheese by taking so many cores. We want to limit the number of cores. So what we are trying to do is to make sure that this equipment can provide similar density as the coring, and then make our quality control testing more efficient and faster.
Let's look at one more project, Moses, and I want to ask you guys another big picture question. Talk to us about what you and your team are doing with the PAVE scan. Well, first of all, tell us what the PAVE scan rolling density meter is, and then tell us what you're doing with it to evaluate asphalt mats and joints. And how are tools like this enhancing the department's ability to really thoroughly and accurately evaluate pavements?
So the PAVE scan is a fantastic piece of technology. You can think of it as a high-tech cart that is pushed or driven over a newly constructed pavement. So what it does is that it sends a ground-penetrating radar into the road to measure density. Like it provides continuous density measurements as you push it. So we are able to get 100% full coverage of the road. And if you, as I said earlier, when it comes to traditional methods, right, we are required to take a few number of course at random locations for a huge project.
Yeah.
So you can think of it like judging the quality of a whole apple pie by eating crumbs.
Yeah.
Right? So if you take the crumbs, you may be lucky and then you get a few a good spot to eat. By doing that, you may also miss some spots that are not well cooked.
Yeah.
Sure.
Yeah.
Or that has problems, spots that have problems. And whatever I said about being lucky and getting good spots, it's also true for being unlucky and then getting an uncooked spot to eat and then missing the good spot.
Yeah. So you need to get a fuller picture, a more thorough picture.
Yeah, you need a thorough picture. And this technology is able to do that.
Wow.
Very cool.
Yeah. So
How does it compare to the NDT version as far as like timing and cost?
yeah, so that is this project is an expansion of the NDT because NDT is spot checks.
Right.
Yeah.
With the electrical.
But it's faster and you can take more spots. Whereas this one covers the entire route.
It's just a little bit slower.
Yes. And like the example I made on the judging an entire apple cake by tasting crumbs, this technology will get rid of that guesswork. So we'll be able to measure the entire road surface. And the objective of our study is to assess this technology and try to develop a framework for its use in Louisiana.
Yeah.
Since we all agree that density is very critical when it comes to the quality of our roads. And we want to measure density everywhere and not just a few random spots.
Yeah.
And that's the purpose of this particular project.
That makes a lot of sense. That's a good analogy too. You know, the pie and the crumbs, but be able to get the full picture. So very good.
Before we kind of end this, was there anything else you'd like our listeners to know about the work that y'all are doing and the ways which it can positively impact their lives as members traveling public using these roads? Maybe they see something, they don't really realize what it is.
So I just want to say that although the projects that we mentioned or the description we provided may sound technical, but our entire mission is to ensure that Louisiana roadway infrastructure is in good shape.
Yeah.
Sure.
So every research that our team, Saman and I, do is to ensure that Louisiana citizens have smoother, durable roads. And by doing so, they will have fewer potholes to dodge. They will also spend less time on construction traffic, and they will be assured their tax money is used efficiently in constructing durable roads.
I want to add that we are constantly and continually collaborating with DOTD, industry, academia, and even public to come up with new ways to help and advance our mixtures in Louisiana.
Yeah. Well, that's awesome. A lot of good work going on here at LTRC, thanks to guys like this. So thank y'all so much for being our guest on the show today. It's so interesting. It's so illuminating to understand more about the research being done here on a day-to-day basis. Now, before we go, we do have one more thing we'd like to do. Have a little bit of fun with you. We've prepared a few final lightning round questions. We got a good assist from some of your colleagues as well. So don't think too hard about these. Garrett's going to ask these. Saman, you'll go first for this section.
So if you could drive or operate any vehicle in the world, what would it be and why?
Oh, I definitely would go with Tesla or an Audi. One of those two. something that can go on an autopilot without my involvement.
One of the other questions I like to ask in a class sometimes is, it's a would you rather. Would you rather live in a world where you could never operate a vehicle before again and all your cars drove for you? Or would you rather live in a world where you could never have autopilot and everybody had to drive everywhere?
I would definitely would go with a road that everybody goes on an autopilot. Yeah.
Love it. Well, we're also told you enjoy traveling. And having lived overseas, could you tell us your favorite country you've had the opportunity to visit?
I would definitely say Portugal is the best country. I have disagreement with my wife about the city, but I think Portugal is one of the best, beautiful
Luckily,
cities.
it's not too big of a country. The cities can't be too far away, right?
I think, yeah, they are within 1 hour, depending on your mode of transportation.
All right, put it on the list,
I
Garrett.
got it. All right, Moses, talking about travel, you already mentioned you're originally from Ghana. Could you talk to us about jollof rice, specifically the differences between Ghanaian and Nigerian versions of the dish, which one you prefer and why, and maybe compare it to jambalaya?
I think Ghanaian jollof is better than Nigerian jollof. I haven't seen someone prepare a jambalaya before, but I can go through how I prepare my jollof
Yes,
rice.
that's what we want.
Love it.
So I will usually cut up tomatoes, like fresh tomatoes, red bell pepper, garlic, onions, some spices.
Any celery in there?
No celery.
Oh, I'm missing the trick.
And then bake it in the oven for about an hour with oil. And then I'll grind it in the blender and then cook it. By then I would have boiled my meat and fried it. So I usually boil the meat in onion. I'll grind the onion with bell pepper and other hot pepper, jalapeno. And then after that, I'll fry the meat. And then I have already ground the tomatoes and other bell pepper that I baked.
Yeah.
And then I cook them in oil until all the water is gone.
Okay.
And then I'll put the rice in it and cook. Rice in the tomato sauce and cook. So you can either cook on fire or in the oven, but I prefer doing it in the oven because that way I don't need to work on it too much. There's minimal intervention right after that. It cooks on its own.
Sounds great.
It does sound good, yes.
I'll be at your house this weekend. Next question. We're told you like Afrobeats as far as music.
Yeah.
Could you tell us who your favorite artist is? And then if we've never listened to that kind of music, maybe a certain artist we could listen to start our journey.
For Ghana, I would say Stone Boy.
Okay.
And then Nigeria, Burna Boy or Davido.
Okay.
Yeah.
We might have to try to look those up and link them in the show notes.
Yeah, we'll put a link to some of that in the show notes. Very good. Well, thanks again to both of you for your time, for everything you've shared with us today. Really great to spend a few minutes with you guys, learning more about what you do and why it matters so much for each of us as members of the traveling public. We're going to step away one more time before we wrap up today's episode. That's a wrap on episode 23 of The Driving Force, presented by the Louisiana Transportation Research Center. You can learn more about what's happening at LTRC on a daily basis by visiting us online at ltrc.lsu.edu or on social media through Facebook, X, LinkedIn, and YouTube. We encourage you, as always, to like, follow, and subscribe to our channels on each of these platforms. You can also learn more about the asphalt research that Moses, Saman, and their entire team are doing by visiting the research section of the LTRC website. You can read our project capsules, final reports, tech summaries, and a lot of other great information there. We hope you'll join us next time. We're going to turn our attention from asphalt to concrete research. We're going to welcome Dr. Zen Liu and Ricardo Hungria. As we did today, we're going to learn more about what their team's discovering through several key projects and show you how that research can positively impact the lives of Louisiana's road users. Until then, we are your hosts, Garrett Wheat and Todd Blunt, and we thank you so much for joining us today. Drive safely out there.